Imagine you are drifting through space, far from home. Ahead of you there is nothing. No star, no light, just a perfect circle of absolute darkness, darker than the night around it. You are looking at a black hole, and you are about to fall in. What happens next is one of the strangest journeys physics allows. So let's take it together, step by step. A black hole is not a thing. It is a place, a region where gravity has become so intense that nothing, not even light, moves fast enough to escape. It forms when a giant star collapses under its own weight, crushing more mass than our sun into a point smaller than a city. The result is a gravitational well so deep that space itself pours into it. As you begin to fall at first, nothing feels wrong. There is no wall, no surface, no warning. You are simply falling faster and faster, pulled toward the darkness ahead. But the black hole has a boundary, an invisible line in space called the event horizon. It is not a physical thing you can touch. It is a point of no return. Cross it, and to leave, you would need to travel faster than light, and nothing can. Here is where it becomes strange. If a friend were watching you fall from a safe distance, they would never actually see you cross that line. Because near a black hole, time slows down. The closer you get, the slower your clock ticks compared to theirs. To them, you would appear to fall slower and slower, freezing at the edge, your image stretching and fading, dimming into red, until you simply vanish from view. From the outside, you never quite arrive. But from your point of view, something very different is happening. You feel no slowing at all. You cross the event horizon without even noticing. There is no fanfare, no barrier. You are now inside a black hole, and the universe outside is sealed away forever. Now gravity begins to show its true power. A black hole does not pull on all of you equally. It pulls harder on the parts of you that are closer to its center. If you fall feet first, your feet are pulled far more strongly than your head. You begin to stretch. Slowly at first, then violently. Scientists have a name for this. They call it spaghettification. You are pulled into a long, thin strand of matter, atom by atom, as the difference in gravity tears you apart. For a small black hole, this happens before you ever reach the horizon. But for a truly giant one, a supermassive black hole, millions of times heavier than the sun, the pull is gentler at the edge. You could cross the horizon intact, alive, falling deeper, with the strangest view in the universe waiting for you. Because as you fall inward, light itself falls with you. The entire history of the universe outside speeds up above your head. You might see the future of the cosmos play out faster and faster in the shrinking window of light behind you. And ahead of you lies the heart of the black hole. The singularity, a place where, according to our current physics, density becomes infinite, and space and time as we know them simply break down. The truth is, no one knows what happens there. Our equations stop working. The singularity is not just unknown, it may be unknowable. A question the universe refuses to answer. So would you feel the end? Probably not as a moment. As you approach the center, the stretching becomes infinite, time itself runs out, and the concept of a next second ceases to exist. There is no after. For you, the story simply stops. But here is the part that keeps physicists awake at night. Information. Everything that made you, every atom, every memory encoded in your brain, should, according to the deepest laws of physics, never be destroyed. And yet a black hole seems to erase it completely. This contradiction, known as the information paradox, is one of the greatest unsolved problems in all of science. It hints that our understanding of reality is still missing something profound. And black holes are not rare monsters hiding in distant corners. They are everywhere. There are hundreds of millions of them in our galaxy alone. And at the very center of the Milky Way, the galaxy we call home, sits a supermassive black hole 4 million times the mass of our sun. We are, all of us, quietly orbiting one. Right now. For most of history, black holes were only a prediction. A strange solution buried in Einstein's equations that even he doubted was real. But in 2019, humanity did something extraordinary. We took a picture of one, a ring of glowing gas around a shadow, 55 million light years away. Proof that these impossible objects truly exist. So the next time you look up at the night sky, remember this. Hidden in that darkness are doorways where the rules of reality bend and break. Places where time stops, where space pours inward, where the universe keeps its deepest secrets. We came to the edge of everything we understand. And we looked over. This is Event Horizon. Subscribe, and we'll keep exploring the universe, one impossible question at a time.